Hello everyone, my name is Mohammad Bilal Fayaz and my group name is Linked Keys. My group members are Sudais Beg, Umar Ziauddin and Aliza Salim. The data structure that has been assigned to us is a Cartesian tree. A Cartesian tree belongs to the class of trees. It is a binary tree which is constructed on a heap property. What makes this tree interesting and different from other trees is that it has both the properties of a binary tree and a heap. Using the tree property, the Cartesian tree is formed from a sequence having a node for each number in that sequence. Cartesian tree does not use sorting algorithm. Instead, it partially sorts the data and can be used priority queue to completely sort it. To use the heap property, the tree must be either a max heap or a minimum heap. If it is a minimum heap as given here, then the parent of any node has a smaller value than the node itself. Based on the heap property, the Cartesian tree, the root is the smallest number in the in-order sequence. The left subtree consists of the values earlier than the root in the in-order sequence, while the right subtree consists of the values later than the root. An in-order traversal of the tree would give the original sequence used to form the tree.
Now let's talk about the application. Our application works on a provided CSV file, which is the data for information regarding the reported COVID cases, recoveries, deaths, etc. This data is for all the countries around the world. Now, what our application does is that it sorts the required data using Cartesian tree with priority queues to give maximum or minimum of any wanted category from the given data. This maximum or minimum value is not just one value, but rather multiple values in a range, like top 10 or worst 10, or top 100 or worst 100. The problem that our application aims to solve is to help in observing the most affected and the least affected countries around the world going through COVID. And to solve this problem, we are using Cartesian trees to sort with the help of priority queues and maximum heap property. The operations or functions that we use to implement Cartesian trees are these. We use add node with complexity O of log n, in-order traversal with O of n, find max node having complexity O of log n, and priority queue with O of n. So the total complexity of Cartesian tree is linear, that is O of n. These are the references that we've used in our slides and in the overall project as well. Now my groupmates Omar and Sudesh are going to talk further about our application in detail.
Hello everyone. I will be explaining the GUI of our project. I will demonstrate what this application is all about. The main goal of this project was to provide a better statistical analysis of the COVID cases all over the world by using data structures known as the Cartesian tree. I will be going over the interface of our project. This interface was created using Tkinter Python library. Our program is linked to a database containing information about all the types of COVID cases in different countries throughout the world. This is what the first form looks like. This form appears when you load the application. As you can see, we can select the categories. The categories include confirmed cases, confirmed deaths, recovered cases, active cases, incidence rates, and fatality rates, etc. Our data structure, the Cartesian tree, allows us to run ranged queries and arrange data in maximum and minimum orders and in a reduced time complexity. To utilize this attribute of our data structure, we have an option to sort the data from minimum to maximum or from maximum to minimum. And we also have the option to select the range queries. That being that we display the data of the top 5 countries in the world, of the top 15 countries, or the top 30 countries in the world. Let me just select a query here and show you the display data. If I select the number of confirmed cases to be displayed from maximum to minimum of the top 30 countries in the world, and I click on proceed, this is what the results look like. As you can see that the data is sorted with respect to the confirmed cases. That being India is leading with the confirmed cases and Brazil has the least confirmed cases. If I close this form, I can just go back to the original form. Here I can select another query and display the data again. There you go. All this data that you see was taken from Johns Hopkins University regarding the ongoing global pandemic. You can find the reference to this in our slides. All the resources are uploaded on GitHub repository along with the original code and our Python implementation of the Cartesian tree. Now, Omar will explain how we constructed the Cartesian tree and how we implemented it and made use of it in our application.
So before understanding the construction of Cartesian tree and how our code is implementing Cartesian tree, it is important here to understand that what Cartesian tree actually is. How Cartesian tree actually works and how Cartesian tree is actually constructed. So here I will first try to explain the construction of Cartesian tree with an example of a simple array so that we can build a good understanding of how Cartesian tree is actually constructed. So let's assume we have this array and the first element of array is number 1. So that will be our first node. As we can see, after that we will iterate over upon our array, and the second element which we have is 14. So first here we have to understand that our Cartesian tree is basically built upon maxi property, and maxi property means that the maximum node should be at the top. Each parent node should be greater than its child nodes. And another property of Cartesian tree is that each recent node should be at the most right. Each recent node should be at the most right. So the next element which we are accessing is 14. And so by default, 14 should be placed on the right of the first node, which is this is how it should be implemented. But based on the maxi property, 14 can't be below 1, as 14 is greater value than 1. So basically, it should replace it, and 1 should then become the left child of 14. So 1 did not become the right child of 14, but the left child of 14, because 14 was the last node, and according to the Cartesian tree, the last node should be on the right. After that, the third element is 5, and by default it should be on the right of the last node, and last node is 14. So yeah, it is on the right of the last node, and since 5 is less than 14, so basically it is correctly placed on its position. The next node which we have is 0, and by default 0 should be placed on the right of the last node, and last node is 5. So yes, 0 is placed on the right of the last node, and since 0 is less than 5, so it is correctly placed as it is a child of 5. And after that we have the last element of our array, which is 8, and again by the property of Cartesian tree, each recent node should be placed at the right of the last node, and so it should be placed at the right of the last node, which was 0. But here it is contradicting with our Cartesian tree property, that maxi property, that child cannot have a greater value than its parent. So which means that 8 should change its position, and 8 should change its position until it reaches a node which have its bigger value than its own value. So 8 should actually replace its position with 5, because 8 is greater than 0, and also 8 is greater than 5. And in doing so, we will end up creating this sort of structure, and this is what Cartesian tree should actually look like. Here we can see that 8 is now the right child of 14, and 5 is then placed on the left of 8, because 5 is less than 8, so it should be a child of 8, and also 5 came before 8, so it should be on the left of 8. And then 0 is on the right of 5, because 0 is less than 5, so it should be a child of 5, and also that 0 actually came after 5, so it should be on the right of 5. So, and ultimately 8 is the last element of array, and we can see that 8 is basically the last, the most right node of our whole Cartesian tree. So I hope that I was able to explain the basic construction of Cartesian tree. And this whole idea is actually implemented by our code at the back end. So this is how Cartesian tree is actually constructed, and this whole idea is what we have tried to implement in this algorithm. So this is the class of Cartesian tree, and once that object of Cartesian tree was made and that list of COVID node was passed, COVID data node was passed to this object, then Cartesian tree is constructed. And Cartesian tree is constructed by two main functions which actually produces this Cartesian tree. The first one is add node function, which actually produces creates the node, fills it with these required values, and then it calls the function this function find max node. This find max node is basically a function which actually checks that the new node is actually being placed in its right position, or it basically checks that it is have a greater value, must have a less value than its parent, and in order to do so, it just traverses, it just runs an algorithm, and it traverses along with the nodes, and it just finally gives us the right position, and then we just make the necessary connections as we generally make in all sort of linked lists and other structures. So we just make the necessary connections, and ultimately we are able to produce a Cartesian tree. Once we are done with Cartesian tree, but we haven't reached some sort of sorted tree, because Cartesian tree is not a sorted tree. Cartesian tree is a partial sorted tree, because it just maintains one, you may say, one idea that each parent is greater than its child, but it doesn't maintain any order between the child of any one parent. The left one could be greater or right one could be greater. There is no particular, you may say, there's no particular idea that which one of them would be greater. So Cartesian tree is a partially sorted tree, and in order to make it completely sorted, we use this data structure, which is priority queue. Priority queue actually works with Cartesian tree in order to make it completely sorted tree, or produce a completely sorted list out of that tree. And then we have just made this code of priority queue, and priority queue just uses this root node of our Cartesian tree. It traverses below that, and finally produces some sort of a list, which is it returns a list, and this list contains basically the nodes which are correctly ordered. Once that sorted list is produced, that sorted list of nodes is produced, then this sorted list of node is basically fed to our new window form, which is the actual result form which the user sees, our GUI shows, and that list is then basically fed to our table, and this is how we are showing that proper results. So basically, this is the whole working of Cartesian tree. It is working on 4 files. We have almost 5 classes. 2 of them are the most important classes. One of them was class of nodes, and other of them was the class of Cartesian tree. So why we chose Cartesian tree to do this sort of sorting? Why we didn't use other sorting algorithms? Cartesian tree is chosen and is widely popular because of its complexity. Cartesian tree does this sorting task with a linear time complexity, as it is not it doesn't take much space and much time in order to perform sorting on even large objects and even large structures. Another advantage of Cartesian tree is that Cartesian tree always maintains the original input with which the Cartesian tree was actually constructed. Whenever we traverse this Cartesian tree in order, so it will return us the original input array which was used to construct the Cartesian tree. So it maintains the originality of the data which was actually fed to make the Cartesian tree. This is how it makes Cartesian tree unique from other data structures and other trees. Thank you for listening. I hope you like our presentation.